History is usually written in the records of kings and the ruins of monuments, but the unfiltered evidence of human survival is found in ancient trash heaps and the stomachs of the dead. This research relies on taphonomy. Taphonomy is the study of how organic matter decays and fossilizes over time. Because organic material is biologically designed to rot, the survival of a prehistoric meal requires a rare combination of environmental factors to halt decomposition. We are opening 6 time capsules. By applying molecular forensics like mass spectrometry and DNA sequencing, archaeologists are beginning to solve culinary cold cases that have been frozen for millennia. These finds provide physical proof that early humans possessed a targeted understanding of chemistry and food preservation, utilizing methods that anticipated modern logic. At rank 10 is the Speyer wine bottle, unearthed from a Roman tomb in Germany. Dating to roughly 325 AD, the Romer wine remains a fluid mass, though its alcohol content evaporated long ago. The preservation was the result of a specific Roman technique, pouring a thick layer of olive oil over the wine before adding a hot wax seal. This created an airtight barrier that pickled the wine in its own container. Today, museum curators refuse to open it, fearing that exposure to the air will cause the ancient liquid to irreversibly decompose. Rank 9 takes us to the ancient Chinese capital of Xi'an. In 2010, researchers discovered a 2,400-year-old liquid bone broth inside a sealed bronze cooking vessel known as a ding. The pot was unearthed from a warrior's tomb, with the liquid still sloshing inside. Over 2 millennia, the broth turned a vivid green as the bronze container oxidized, leaching metals into the soup. These 2 finds demonstrate that ancient burial practices utilized sophisticated vacuum sealing techniques to sustain the deceased, utilizing anaerobic environments to prevent evaporation for thousands of years. At rank 8, we look at the tomb of Ptolemais, a 13th century BCE Egyptian mayor. In 2010, archaeologists found a solidified whitish mass wrapped in canvas inside a broken jar. Laboratory analysis confirmed this is the oldest solid archaeological residue of cheese ever found. It was a blend of sheep and goat milk with a moist, spreadable consistency that survived the extreme heat of the Saqqara necropolis. Chemical analysis revealed a biological danger hidden in the dairy's proteins. Tests detected traces of Brucella melitensis. Brucella melitensis is a highly infectious bacterium responsible for brucellosis, a disease that causes recurring fevers and chronic muscle aches. Consuming this unpasteurized dairy would have led to a debilitating long-term infection. This find provides the oldest reported biomolecular evidence of a disease that still affects modern agriculture. The discovery shows that while ancient Egyptians were skilled cheesemakers, they were already dealing with the health risks associated with early animal domestication and dairy production. Rank 7 was preserved by a sudden natural disaster at the Lajia settlement in China. 4,000 years ago, a massive earthquake forced a diner to abandon their meal mid-bite. An overturned clay bowl trapped the food in an airtight chamber beneath 10 feet of sediment. The discovery of these thin, yellow strands proved that noodles originated in Asia, though they were crafted from indigenous millets rather than wheat. For rank 6, we look at Otzi the Iceman, a 5,300-year-old mummy discovered in the Alps. Because his body freeze-dried in a glacier, his stomach contents remained intact. Forensic analysis shows his final meal consisted of nearly 50% fat, paired with wild ibex and red deer meat. This high-fat intake provided the caloric density necessary to survive in a frigid, high-altitude environment. Researchers also found traces of toxic bracken fern in his system. This suggests he may have been using the plant as a primitive treatment for a chronic whipworm infection, though the fern itself is known to be harmful. These meals show that Neolithic humans possessed a functional understanding of nutrition and botanical properties, selecting foods that addressed the specific energy and medicinal needs of their environment. Rank 5 brings us to the Upper Amazon of Ecuador. At the Santa Ana la Florida archaeological site, researchers analyzed ceramic vessels dating back 5,300 years. Scientists identified microscopic starch grains and DNA belonging to the cacao tree. This evidence proves that cacao was domesticated 1,500 years earlier than history previously recorded. This find identifies the Amazon basin, where the genetic diversity of the cacao tree is highest, as the original home of chocolate, moving the timeline of its use far earlier than its appearance in Central America. The presence of cacao residues on trade-related artifacts suggests that chocolate was a foundational component of South American trade networks long before it reached the civilizations of Mexico. From the identification of pathogens in Egyptian dairy to the high-fat diet of the Alpine Iceman, the evidence shows that our ancestors invested significant labor into the processing and preservation of their food. These discoveries suggest that food innovation, developing the means to press oil, brew beer, or seal broth, was a primary driver behind the expansion of early human societies and trade. Every time you eat a bowl of noodles or taste chocolate, you are connected to a lineage of culinary chemistry that science is only just beginning to map at the molecular level. From the identification of pathogens in Egyptian dairy to the high-fat diet of the Alpine Iceman, the evidence shows that our ancestors invested significant labor into the processing and preservation of their food. These discoveries suggest that food innovation, developing the means to press oil, brew beer, or seal broth, was a primary driver behind the expansion of early human societies and trade. Every time you eat a bowl of noodles or taste chocolate, you are connected to a lineage of culinary chemistry that science is only just beginning to map at the molecular level. We traditionally attribute the birth of complex food production to Bronze Age empires, civilizations that had already mastered metal tools, the wheel, and written language. But the molecular structures hidden in the prehistoric record suggest a different origin. In the Near East and the Caucasus, researchers recently analyzed two separate caches of organic residue. Both date back to 5800 BC, a period we once considered to be dominated by simple, small-scale survival. These chemical fingerprints have survived in a state that defies the standard timeline of organic decay. After 8,000 years, their chemical profiles remain nearly identical to modern samples. The evidence includes residues of olive oil processed in massive quantities and 300-liter ceramic vats used to ferment wine. These molecules provide empirical proof that Stone Age populations were operating as sophisticated chemists and master horticulturists thousands of years before the rise of the first formal cities. The first investigation took place at Ein Zippori in Lower Galilee, Israel. During a routine highway expansion, excavators uncovered a series of clay storage pots belonging to a community from 5800 BC. Archaeological researchers Yanir Malevsky and Nimrod Getzov led the forensic effort, testing the organic compounds absorbed into the porous ceramic shards of these vessels. The analysis focused on lipids, a category of organic molecules including fats and oils that do not dissolve in water. When the lab ran the tests, the ancient lipid profile matched flawlessly with a modern 1-year-old olive oil control sample. The scale of the find is what changes the narrative. The sheer volume of storage jars recovered suggests that Neolithic people were pressing oil on an industrial level for the entire community, rather than producing it as a rare luxury. By 5800 BC, these Mediterranean populations had already cracked the mechanical and biological codes necessary for mass agricultural processing, long before they had ever used a wheel. 600 miles to the north, in the South Caucasus region of Georgia, Professor Patrick McGovern's team launched a parallel investigation in 2017 to find the origins of winemaking. They focused on colossal earthenware jars, some with a 300-liter capacity, found at 2 separate sites. These vessels are the ancestors of the kvevrey, large, egg-shaped clay containers traditionally used in Georgia for fermenting and aging wine. Most ancient alcohol residues from later periods contain traces of pine resin. Early brewers used this resin to mask the flavors of bacteria and spoilage that occurred during the fermentation process. But the Georgian samples lacked resins. Testing identified tartaric acid, naturally found in grapes. This suggests 8,000 years ago, they bred grapevines into hermaphroditic forms, containing male and female organs, allowing self-pollination to create high yields for pure vintage. This discovery identifies the world's first pure wine, proving that prehistoric humans were intentionally manipulating plant genetics to meet specific cultural and ritual demands. The findings from Israel and Georgia establish that the Mediterranean triad, the dietary foundation of grain, legumes, and oil or wine, was already a reality in the Stone Age. We previously believed this dietary system was a later development of large-scale empires. The chemistry proves it was firmly established 8 millennia ago. Climate data shows that 8,000 years ago, the South Caucasus and Galilee experienced higher rainfall and more moderate temperatures than they do today. These conditions provided the environment necessary for this significant acceleration in human innovation. The labor required to harvest, process, and store these products at this scale suggests a population of intentional engineers. They were moving beyond simple foraging to master a labor-intensive system of production. This entire agricultural infrastructure was built without metal tools, mechanized transport, or even a written language to record the chemical formulas for fermentation. It reveals that the sophisticated gastronomy characterizing modern society was not a gradual achievement of the last few thousand years. It was perfected 8,000 years ago by masterminds working at the very beginning of human history. Deep inside the Raqefet Cave in modern-day Israel, 13,000-year-old human remains lie half-buried in the dust. These bones belong to Natufians. They were a society of nomadic hunter-gatherers who survived by foraging. They possessed no farms, no domesticated crops, and no advanced technology. This image shows a heavy stone mortar and pestle found right alongside the bodies. The deep, carefully carved basin reveals it was designed for heavy, repeated grinding. Standard historical timelines state that humans first settled down to farm grains, specifically to bake bread for daily survival. Alcohol, according to these timelines, was a byproduct discovered thousands of years later. But the chemical residues trapped inside the pores of these stone tools reveal a sequence that does not align with the traditional timeline. This graveyard holds the oldest verifiable record of man-made alcohol on Earth. The Natufians were brewing drinks millennia before anyone planted the first grain of farmed wheat. This photograph shows the Stanford University campus, where an archaeological team led by Li Lu launched a forensic investigation into these ancient tools in 2018. Macroscopic observation of the stones couldn't explain their purpose. The team had to scan the porous basalt surface at the molecular level to determine exactly what the Natufians were crushing inside them. Deep inside the stone matrix, they found preserved starch grains and microscopic plant particles called phytoliths, rigid silica structures that form inside plant tissues and remain after the plant decays. A phytolith acts as an indestructible botanical fingerprint. When a plant decays, its organic matter disappears, but it leaves behind a rigid structure that perfectly matches its specific species. This image shows wild barley and wheatgrasses, the exact botanical species that match the microscopic phytoliths extracted directly from the cave mortars. The heavy concentration and physical breakdown of these wild grains proves the Natufians were not haphazardly crushing seeds for a quick meal. They were executing an intentional chemical engineering operation. The Natufian brewing process began with malting, deliberately germinating wild grains for fermentation. Next came mashing, where grains were heated to convert complex starches into fermentable sugars. Finally, fermentation allowed wild airborne yeast to interact with the mash, producing alcohol. The resulting beverage looked nothing like a modern liquid beer. It was a thick, multi-ingredient concoction resembling a porridge or a thin, intoxicating gruel. Gathering wild, uncultivated grains by hand is labor-intensive. Converting those hard-earned calories into a low-nutrition alcoholic gruel is mathematically inefficient for a hunter-gatherer trying to avoid starvation. Because this operation required more calories than it provided in return, it offered no advantage for basic physical survival. The immense effort had to serve a specific alternative purpose. This brings us back to the stone mortars resting next to the bodies. Why execute a grueling, calorically negative brewing process inside a mass grave? The physical evidence supports the beer before bread hypothesis. This theory suggests that the human desire to experience altered states of consciousness, emerged before the desire for stable, farmed food supplies. Brewing this labor-intensive drink within a cemetery suggests it served a social purpose. These ritual feasts allowed the Natufians to honor the dead and maintain community bonds through a shared, high-cost experience. Supplying alcohol for these culturally vital rituals required massive amounts of wild wheat and barley, creating a demand that naturally occurring crops could not meet. Humans did not endure the hardships of inventing agriculture merely to secure a reliable source of bread for daily nutrition. The grueling spiritual and social demand for alcohol was the actual catalyst that forced humanity to domesticate crops, ultimately launching agrarian civilization. Deep in the arid expanse of northeastern Jordan lies the Black Desert. Here, at an excavation site known as Shubaika 1, researchers uncovered an anomaly hidden in the dirt. While digging through the remains of a semi-subterranean flagstone building, archaeologists focused their attention on a specific circular structure, an ancient fireplace built from local basalt stone. Resting inside that stone hearth were 24 charred, seemingly unremarkable crumbs. These burnt fragments represent a physical anomaly, evidence of a complex food technology used long before we believed it was possible. Every standard history curriculum teaches a strict sequence of human development. First, our ancestors invented farming. Then, with a reliable surplus of domesticated grain, they figured out how to mill flour and bake. But when researchers put those charred crumbs through radiocarbon dating, the results came back at exactly 14,400 years old. This timeline illustrates the problem. The first evidence of organized farming appears roughly 10,000 years ago, but these artifacts were left behind 4,000 years earlier. The historical sequence we rely on breaks down completely right here. According to the archaeological record, the domesticated grains required to make anything resembling those crumbs did not exist yet on Earth. If the radiocarbon dates hold up, the mere existence of this material is a physical impossibility. To figure out what these hunter-gatherers were actually burning, scientists had to look closer. A team of archaeobotanists from the University of Copenhagen took possession of the fragments to conduct a forensic analysis. They placed the samples inside a scanning electron microscope. A scanning electron microscope, or SEM, is an instrument that produces highly magnified images by scanning an object's surface with a focused beam of electrons, revealing details at the molecular level. Under high magnification, the burnt debris lost its resemblance to random plant matter. The scans revealed a highly structured vitrified matrix, a solid material that had been chemically transformed by intense heat. This chart visualizes the internal geometry of that mass. By measuring the cross-section, researchers determined that exactly 16% of the crumb's volume consists of empty, porous pockets. Those microscopic voids form a distinct cellular fingerprint. They are the exact remnants of gas expanding against a solid matrix, the mechanical action that occurs when dough is kneaded and baked. The cellular data is definitive. The Natufian people at Shubaika 1 had intentionally mixed and cooked an unleavened flatbread. The microscopy also identified the specific raw materials trapped in the dough. These hunter-gatherers were foraging for wild ancestors of modern cereals, specifically uncultivated einkorn, barley, and oats. To bind these dry grains together, they added a highly specific starch. They harvested the root-like tubers of an aquatic clubrush plant, a leafy weed belonging to the papyrus family. Gathering these ingredients is not like walking through a modern wheat field. These wild plants are tough, sparse, and require immense physical effort to isolate and collect without specialized harvesting tools. Once collected, the material had to be processed. The scans show that the flour was ground so incredibly fine that absolutely no whole grains or chaff survived in the final product. To achieve that powdery texture, prehistoric humans had to manually crush and sieve these rigid seeds against raw stone for hours on end. For nomadic foragers whose daily existence revolved around basic caloric survival, expending this amount of exhausting labor to produce a single flatbread defies biological logic. This reveals a serious caloric paradox. The sheer energy expended walking miles to find wild seeds, harvesting them by hand, and grinding them on stones burns significantly more calories than the final thin piece of bread actually yields. A human living on the edge of starvation operates on strict efficiency. They do not waste precious energy hunting down a food source that results in a net caloric loss. Researchers resolved this paradox by analyzing the cultural context. This flatbread was never meant to be an everyday survival meal. It was a rare, labor-intensive delicacy, intentionally crafted for specific social or spiritual events. The drive to consume this specific, complex food was so strong that it completely overrode the basic biological math of prehistoric survival, which brings us back to the Speyer 1 site and a conclusion that reverses the accepted historical timeline. Early humans did not settle down and invent farming simply to secure a stable food supply, only to accidentally discover baking with the leftover surplus. Instead, these hunter-gatherers already knew how to bake. It was their intense desire to secure a steady, easier supply of grain for this specific ritual flatbread that directly pushed them to domesticate plants. The labor required to produce this bread was the likely catalyst that drove nomadic groups to settle and begin the domestication of wild crops. Which one do you find most interesting? Please leave a comment below. And if you like the video, please like and subscribe. Thanks, and see you next time.